Hey guys, welcome back to another video, and as promised I've got a follow-up here to my introduction video last week where I'll be showing you all the parts for the CNC build that I'm doing. I now have everything. I've put a tabletop here on my stand ready to be built on, and I've situated all the parts here ready to give you a run through. So what I'll do is I'll bring the camera over here, walk you through some of this stuff and show you some close-ups, and then I'll jump back on the PC and I'll run you through the parts list and the total cost and all that kind of stuff. Bear in mind this video does have a blog post that goes with it, which is over on my website. That might be a bit more detailed and it might break it down a little easier for you, so be sure to check that out. I'll put it in the description down below. The only other thing I wanted to cover before we jump in is the expectations of this project, right? I didn't really cover that too well in the last video, and I had a few comments wanting some clarity on that. So basically, I have no doubts in my mind that this machine will be a fantastic addition to my workshop. 95% of the work I'm going to be doing is soft and hard woods, and this machine is going to be fantastic. What I want to make clear is I'm not saying that this machine is going to outperform or even be equivalent to an industrial grade CNC of similar spec in terms of the electronics and the power and all that kind of stuff. What I am saying is we can get very, very close to that for a fraction of the cost, half, maybe even a third of the cost. And that's what I'm trying to demonstrate here. Depending on your needs and what projects you're doing, I don't need to be within a thousandth of an inch on a piece of wood. I'm not boring out cylinder heads here, or I'm not manufacturing parts for engines and that type of stuff. For what I want to do here, this is brilliant for me, and it means that I haven't got to fork out 5 to 10 grand to one of these companies to do larger scale projects that don't require that degree of accuracy. So that's what I wanted to make clear. As long as you understand that, if you're going to follow this along, know what you're getting at the end. And for me, I can't wait, to build this for the cost I've managed to do it, and to have that capability in the workshop is just super exciting. So let's jump into it. I'll get you over here and we'll have a look through some of these parts. Okay guys, so here we are at the workbench. I'm going to do my best here to try and talk you through some of this stuff. It is a really big space, so it's hard to get the camera up very high, but I'll do my best to show you what everything is here and what it'll be used for. So I'll probably start off at the back there. So as I said, the machine is made from aluminium plate, really thick solid stuff, and right at the back here are the chassis pieces for the Y of the frame, and on top of it I've obviously got these linear rails. So you can see here this stuff is very, very thick, and I'll do you some close-ups as well so you can see all that. But we have two of those at the back, along with the linear rails, which I've currently got rested on there. And they are pretty damn solid, they're not going anywhere. They're quite heavy, and the idea is that I'm going to drill and tap all the holes in there and bolt the linear rails down to that piece of aluminium. We've got the ball screw here for the Y-axis. There's actually two of those because it's going to be dual motor on the Y-axis. This can really help in terms of keeping everything nice and square. It's additional power as well if you've got a heavy gantry, which in this case it is quite a big bulky gantry. But that's a good thing because it means it's more rigid. So there's two NEMA 23s running that gantry up and down the Y-axis. And again, we've got additional parts here. So these are the X chassis pieces that connect each end of the Y-axis, and there's going to be two holes in each of these bolted to the underside of these Y-axis runners. Again, there are 6 of them. They're very thick also. I might be able to show you one of them if I just move these. So there we go. I don't know how well you can see that, but this stuff is nice and thick, and the idea is they'll run this way. 6 in total, and these will be bolted from the underneath up into these larger Y-axis pieces. And again, there's a lot of drilling and tapping involved here, so I'm going to have to be extremely accurate, but it does save having to weld. Welding is very difficult. You need a flat surface to do it on, otherwise everything else will be out. You have a bit more wiggle room when it comes to bolting things in place. So I think that's going to be quite a pleasant experience. Bit of a task to do all these. There's a couple of hundred drill and taps I'm going to have to do. But, you know, it's all part of the fun and I'm going to enjoy it. So along with that is the X-axis ball screw. That runs across the gantry piece, which is here. So this gantry backplate is very big. If I move some of these quickly, again, these are very heavy, but this is a huge piece, as you can see there, absolutely massive, 20mm thick. So that's going to be the main gantry plate there with a spindle connected to it. Should be awesome. And I've got big thick side plates for that also, which are over here. So a lot of these pieces here are used all over the machine to sort of hold the frame, hold the motors to the frame. These are bearing blocks that I've created to connect these big plates here to the bearings. So in terms of the gantry here, the idea being that this will connect to the gantry there, and then this connects to the bearing blocks, just like this. So you can see I'm going to have to drill through there and tap as well. Over here we have the bearings for the linear rails. There's 12 of them in total, and that's obviously what the gantry will run across, and the spindle will move on the x-axis. In regards to the aluminium plate, you can see here I've been practicing a little bit the last few days. This is a test piece that I bought to just have a go at in terms of drilling and tapping, and I managed to successfully do that, and I've created a nice counter bore on the top. So we've got a hole there with a thread that I created, and that just goes straight in very nicely, nice and straight. And I've bought myself a very good tap and die kit as well over there, which I may show you in a little bit, but that's going to make tapping the aluminium so much easier. There's also a few other tools that are going to be really useful in a project like this. We've got the 90-degree set squares here, we've got a deburring tool, we've got a punch, which is great for drilling accurate holes. So you mark out where you want to drill, give it a tap, and that'll punch it and guide the drill bit where you want it to go. If you don't use one of them, what you end up happening is the drill bit slides around everywhere and you get a bad hole. We've also got a scribe here, which is good for marking out this stuff. A decent measuring tape. I've got a big set square as well, which I'll use on the larger pieces. Some good steel rulers. In here we have all our bolts. So I've got some decent bolts there. These are all marine grade stainless steel. I think in total the bolts came to around £90. They're really good quality. These will be there for life, you know, so it's worth getting good stuff. These are very well made, I can tell just by looking at them. We've got a mixture in here of M5s, M6s and M8s. That's what I've used in the entire build, and again all those are on the parts list as well. Also got a bit of cable management here with the cable tracks. There's another one of them over there as well, and that just sort of lays the cable down as the machine moves to stop anything snagging or getting cut. You wouldn't want that, so that's handy to have. A few things over here, a couple of you guys have seen already. We've got the NEMA 23 closed loop motors. There's 4 of them in total. These alone are very heavy, and you'd be surprised how powerful those are. And a driver for each of them. These are closed loop drivers, CL57Ts, 4 of them. I'm going to be using a Mach 3 breakout board initially to try and get the machine running, just make sure everything's going. I'm very open to what I use to run the machine going forward. Somebody commented on the last video, which I appreciated, about Linux CNC, which I know is widely used. I'm definitely open to that stuff. And again, if you're doing a build like this, you have control over that. And when you know how everything's wired up and how it works, changing out a board to run a different piece of software is nothing. It's quite an easy task. So yeah, I'm open to that. So any ideas or thoughts, suggestions, please leave a comment or head over to the website, leave some suggestions. Really appreciate that. This power supply here is going to be isolated from everything else to run things like this, lower logic boards, trying to avoid interference between any sort of VFD stuff and the microelectronics. And speaking of the VFD, we have that over here. This is going to run the spindle. As you can see, there's a lot going on in there. And the spindle itself is very large, again very heavy, well made. So this is 2.2 kilowatts and it runs at a peak of 24,000 RPM. So you can cut, I'll be able to cut a lot of stuff on here, you know. It will do metal, it'll definitely do things like brass, copper, it will do aluminium as well. This is made using thick aluminium, and once all together it's very strong. So I'll be able to do a lot with thinner sheets of aluminium, and at lower speeds probably even thicker stuff like this. Probably could do mild steel. I'd have to play around with the speeds and feeds, but I wouldn't expect too much in the steel department, because obviously there's a general rule that if you want to machine a material, your machine should be stronger than whatever you're machining, and that's a decent rule. That being said, you don't know until you try it out, and I'll be doing all those tests when this is up and running, and I will find the limits of this thing. What can we do with this budget, and what can the machine do? That's the question I want to answer. The spindle itself is also water cooled, and this all came as a kit. So there's a water pump here, the tube that you use to connect everything up. Has a giant collet on the end, and it came with a bunch of different fixtures for that also. There's a large power supply here, which is roughly, I think it's about 800 watts. And this thing, there we go, yeah, it's 36 volts, 800 watts. And this thing is dedicated to driving the NEMAs. So that's all this is going to do, is power these. And I've tried to separate that out for good reason. I have some cable as well for routing everything, mainly for routing the connections between the drivers and the board and the power supplies. All in all, that's pretty much everything. I have this here obviously, which is the spindle mount, which will connect to the motor plate, which is under there. There are a few other pieces here that I haven't really showed you, but they're mostly just sort of standoffs. There's the Z-axis plate is in there. There's also a motor plate on top of that. There are pieces like this which will go on the edge of the machine, which will hold the ball screw bearings, and also there's a couple of plates to hold these big chunky motors as well. And that's pretty much everything. Believe it or not, when you see it all laid out like this, there's really not a lot to it. When you sort of have the initial idea of building something like this, it's quite intimidating when you look at it built and constructed. But when you break it down, it's just a bunch of parts that talk to each other and fit together. So next up, what I'm going to do is I'm going to clean up a lot of these parts, probably after machining them, but a lot of them are quite dirty. There's writing on them from where they were supplied. And if you have a look here, there's some stuff. I just grab this. There's this stuff you can buy called Autosol metal polish. My dad used to use this on the alloys of his classic car back in the day, and they would always come up looking like new, and you can use it great on aluminium. It's awesome stuff. I don't know if you can see this on camera, but I applied one little drop of it there and just gave it a one little coat over. You can really see the shine on that. So I will clean all these pieces up, and to do that I've got an orbital sander that I use, and you can polish that up really nicely with an orbital sander, and it'll just make the machine look really good when it's built. Not necessary, but it's a nice touch, and I might as well do it. The only other thing probably worth chatting to you about is some of the tools you might need to do this. The only major tool I went out and bought for this is this simple pillar drill. There is nothing special about this one. It cost me £60. It's very, very good. Everything I've done here with these test pieces has been done with that, and I'm definitely going to explore that a little bit more. But having done a couple of holes, I'm super confident that this will do the job. I've got a little vise here as well, so I can get as accurate as possible with the holes. And yeah, this thing, you know, it was 60 quid, not bad at all. So hopefully that covers it. As I said, I'll give you some close-ups. Maybe as I'm talking, I'll overlay some close-ups and stuff so you can get a better look. There's just so much stuff here, it's really hard to get it all in frame. That's the update in terms of the hardware and the parts that I'm using. So now what we'll do is I'll jump on the PC and I'll run you through the parts list and the materials and that kind of thing, show you how you can access that, and go from there. So let's do that. Okay guys, so as I said, this video has a blog post to go with it, which I haven't put up yet, but by the time you see this video it'll be live. Everything I've mentioned here will be in this blog post, but the part you're going to be interested in is down at the bottom. So I've specified here all the specifications, the frame, what my choices there. As I said, it's not finished yet, but I'll get to it. So I've provided at the bottom the CNC cost, and it's an Excel sheet that contains multiple sheets for each of the cost areas for this project. Now I've explained at the bottom there the sort of terms to use in that, and basically I was hesitant to sort of give it away at this stage because I didn't want to give you guys a bunch of parts and sort of say, right, yeah, this is what I'm using, and then somebody out there go and buy these parts, and midway through the build I discover something, I decide, oh, that part needs changing. So I didn't want to be responsible for somebody else losing money because maybe I didn't foresee an issue or something like that. But I've just figured I'll give it out, and it's kind of on you really. So if you're going to use it, whether to do your own project or a spin-off of this type of project, fine. Just do it knowing that it can change at any moment, and you have to be responsible and competent to build it yourself without my guidance. So I'm not going to be doing sort of step-by-step videos on how to wire all the electronics and that kind of thing. What I'll likely do instead is sort of do update videos at project milestones, and that way you can sort of follow along, see how things are going. But what I will try and do is be as detailed as I can in the blogs. It's just hard to cater for everybody in terms of wiring in particular, because with electrical stuff, every country has different regulations. I'm in the UK, I'm confident wiring UK electrics. I know what the limits are, I know what the fuses are here, I know what I can pull in the shed. It's different everywhere else, and I don't want to be responsible for somebody wiring something wrong. So just be aware that you can use this cost analysis sheet if you want to. As I said, it has to be on you, right? Things may change. So what I've done there is provided that Excel sheet. I'll load that up for you now. So I've broken it down. We've got a main sheet here called total cost, and in there I've referenced the costs in the other sheets to give us a total. Now this includes absolutely everything. Everything you see in that image there, everything I've showed you on the bench, including the bench, £2,330, and that is down to the penny. I know everything I've spent, I've tracked it all, and that is the exact cost of buying the parts. Now one thing I'll say in terms of the hardware, I got all this stuff from AliExpress, and I'd recommend you do the same, because I initially had two of these cost sheets going. I had one if I bought the parts locally here in the UK, and one if I bought them and had them imported from China. Now bear in mind, they're all made in China, but if you buy UK stock, you're paying an absolute premium on these parts. And honestly, if I had bought all these UK stock, it would have been an extra £500, and I'm not exaggerating that. Buy from China and have it imported. Yes, you might have to wait 2 weeks, sometimes even a month for delivery, but if you can do this ahead of time, you will save so much money. And that goes for any project. Plan ahead, allow for delivery time, and you just save a stupid amount of money. You may even be able to shave some money off this as well, because at the time I purchased these two here, they charged me shipping costs. I paid over £110 in shipping, which I included here in the cost. So if I hadn't included shipping, you know, that's even less again, and potentially more money saved if you can get a better deal somewhere else or something like that. But I was completely transparent with all the costs. You can see them all in here. I'm working it out. Shipping has been included, as you can see. That's all in there. So I'm not going to go through all these parts again, because obviously I've just shown you on the bench. But run through these, everything's there. Moving on to the frame materials. So this is everything based on the CAD designs, and it's everything you've seen on the bench there. And that's the total cost for the aluminium plate. I did initially have a steel calculation as well. The problem was steel was way harder to source from my local area than the aluminium was, which was also a factor in choosing the aluminium. But in the quote, they provided me an incomplete quote with things missing, and it was already up to sort of £1,400. So the steel will cost you more. If you go for stainless steel, that's outrageous cost. You'd be spending 2-3 grand probably. It's very expensive. So what I did was I sent them this part here exactly as you see it. I said this is what I need at these sizes and the quantities I want. They got back to me with a quote with this figure, which was a fair one, and I ordered it and it arrived in around 2 weeks. I've done the same thing. I've included everything in there. So I used the 3x2 wood to build it. I was ordering stock lengths of 2.4 meters for some of the larger parts, but again, just go with what you need, and usually they'll work out the cheapest possible option for you. I've included the casters there and even the screws that I used, and we've got our total cost. The bolts, this one took me a while to put together. I used a company called Bolt World. Again, I'm not affiliated with any of these, by the way. They're just what I decided to use, and I did pay for everything. There's no affiliate links in here whatsoever. Again, I had to go through the CAD design and work out what was being used where, and this took me like a good day to do this. But everything's here, as I said. The total was around £90. All high quality stuff. I put links here to where you can get the generic bolts, and there's links to the individual sizes too. Again, you might want to use a different one, that's fine. You might get it cheaper somewhere else, but as promised, I've tracked all the costs, provided the information for you, and so from here you can do with it what you want. I'm going to carry on with the project like normal. If I was in your position, I'd hang around, see how it goes for me, and then depending on the outcome, maybe you can make a better informed decision, and maybe even save yourself money like I'm hopefully going to do here. Well, I know I'm going to do, because if I bought this spec machine from an industrial supplier, you can triple this number at least. So yeah, that's it. So back to the blog post here. I mentioned the total cost. I'll add some more information in here before I publish the video, but that's where I'll leave this one. I'm really excited to start the project. I appreciate all the support and the interest around it. Thank you so much for watching. I hope you learned something as always, and I'll see you in the next video.